Hello and welcome to Computer Tech and More. Today I'm going to compare the performance of my desktop and my Zephyrus G15 laptop, as well as a couple other computers that I own. So first and foremost is an Intel NUC 8259U. It's a couple generations old at this point, but still relevant in terms of performance, I feel like. A Lenovo C940 Yoga, which has a 1065 G7, my old desktop, which was an i7 6700K, the Zephyrus G15, which has a 5900HS, and my current desktop, which is 11700K. So first I'm going to use an encode test using Handbrake and their X264 encode 720p preset. It's up on screen. That's the naming. I just have a 30-minute test video that I ran, and the first one is how much wattage each CPU pulled. So first thing I want to note is that the Zephyrus G15 can pull up to 65 watts and max sustained, and this is under the highest profile setting. Under normal conditions, it pulls 35 to 45 watts. So in silent mode, it runs at 35 watts. In performance mode, it can boost up to 45, ignoring spikes. This is sustained type load. And then in turbo, it can sustain a 60 to 65 watt, depending on, at that point, temperatures. And this is a CPU only load. I want to specify that explicitly for that. As soon as you start loading up the GPU, the amount of wattage that the CPU can take diminishes. The 6700K pulls 94 watts. And I need to mention that this is all when reported by HW Monitor, hardware monitor. So actual at the wall power may differ, will differ, but this is how much wattage that it says it's pulling from hardware monitor. The i7 1065 G7 pulled 24 watts and some change, about 25. And the i5 8259U pulls 33 watts and some change. So first and foremost, the 11700K is an 8-core 16-thread. The Ryzen 5900HS is also an 8-core 16-thread, did I say? 12-thread for the first one. You know what I mean? 16. The 6700K is a 4-core 8-thread. The i7 1065 is a 4-core 8-thread, and the 8259 is a 4-core 8-thread. Personally, I'm going to just put this out there. A dual-core, using it for encoding, I wouldn't. They're way too slow. I do have data on it for a couple older models, but it's just not applicable. They're just too slow. And my older ones, the wattage was just too high. So the average frames per second for the 11700, I'm going to shorten the names so I can talk through it faster, was 109. For the 5900 was 90. For the 6700, 44. For the 1065, 29. And for the 8259 was 31.7. So the 4 cores are all pretty similar. Obviously higher clock speed for the 6700 at 4.3 gigahertz is quite a bit faster. And I wanted to show that there is a remarkable improvement in frame per second between the generations, but this isn't the whole story. And Ryzen, of course, is very fast. Excuse me. So this is a time to finish. It's just another way of looking at kind of frames per second. So the 11700, 5 minutes, 6 seconds, 5900HS, 6 minutes, 55 seconds, 6700, 13 minutes, 17 and 17, almost identical. And there is a clock speed difference between the 1065 and the 8259, which is again, showing generational improvements that Intel had made. So next is frames per second per thread or core. And I just did simple math, dividing the frames per second by the number of threads. And you can see that the 11700 has much more performance than the rest. And what's really remarkable is just how high the 6700 still manages to punch despite being over 5 years old, where the amount of performance per thread was very similar between the laptop and the desktop, despite its clock speed disadvantage for the laptop 5900HS. Next is frames per second per core per clock. So this takes into account the clock speed of the processor. So the sustained for the 11700 was 4.7 gigahertz, the 5900 was 4.09, 67 4.3, the 1065 was 2.6, and the 8259 was 3.1. So right here, between the 11700, you get 1.449, 5900, 1.375. I don't want to really read all the numbers to bore you guys watching this, but you can see it, it's up on screen. But basically, bigger number, better performance per clock. Next, I did frames per second per watt. So here it takes how much performance you're getting and dividing out how much power it's using to get that performance. Ryzen, hugely more efficient. The more modern Intel Mobile actually does pretty good compared to their desktops, but nowhere near what I can get with the Ryzen, which is why I use it for light encoding as well as gaming and Plex server. It just, hands down, has so much more performance per watt. Next, we're going to look at the performance that I got with TimeSpy. I'm going to just leave it up on screen. So the 11700 got the most, and it scales down from there. And then TimeSpy frames per second per thread. So again, this divides out how many threads there are in it. And you can see that even the 6700K really has a good amount of performance in its threads. It actually beats out the 5900HS. Next, in Firestrike, it's the same sort of story. Scales down. I don't want to read all the numbers and bore you, but I'll leave it up on screen for long enough for you to read the numbers. And then the next one was at the extreme. I did not run the laptop, the two kind of everyday laptop processors or NUC processor in it because they don't have discrete GPU, so they just don't make sense. And then the 3D Mark CPU test. This one, if you haven't run it before, it has a varying amount of threads, and each time it reduces the number of thread count to check the CPU utilization from maximum threads to like one thread. So it checks how performant you are at one core and multi-core. But these are the numbers that it generated. So once again, the 11700, it's a desktop processor. It should be the fastest. But the 5900HS does have a solid amount of performance. And then 3D Mark 11, still a favorite. Oh, I'm misreading my test. Sorry, I jumped ahead. This is 3D Mark 11. My bad. And this is the frames per second per thread per core. Sometimes I just jump ahead of myself and misread. But it just kind of shows the relevance of certain processors. Either one of these lighter laptop processors, if you pair it with an external GPU, something like a 1070, You get great gaming performance if you want to hook it up to a TV. But here we go. And last and certainly not least, this is the 3D Mark CPU test, the one that I thought I was just looking at a second ago. So this is the one where it tests versus number of threads, and it decreases the thread count so that it will utilize fewer and fewer processor cores, so you get to see the performance of the whole CPU package all the way down to a single CPU core. So this is the max test. And interestingly, the 8259 does outperform the 1065 G7 in this. I did personally find that my Lenovo laptop, the one that has this 1065 G7, does seem to thermal throttle itself even in high performance mode. It really could utilize a little bit stronger cooling and it would get much more performance. But it's an older laptop at this point, 2019 model. All right, in 16 threads, I mean, this perfectly makes sense. This is a desktop processor. It's not going to thermal throttle very much, if at all. This is a mobile CPU. It should thermal throttle at some point, although it technically does not for me when under turbo fan profiles in Armory Crate. And then under 16 threads, you can see that the two laptop processors actually get very close to the 4.3 gigahertz of the 6700K, despite being 2 and 4 years more modern, or less modern. And then 8 threads, you can, sorry, I didn't calculate percent differences, but visually it looks to me like it's closing the gap between the desktop and the laptops, and these two are closing the gap a little bit. So once you're in 4 threads, they're the 1067 and 5900HS, relatively speaking, close performance, and even the 6700K is pretty close in there, and the two laptops, lighter laptops, get pretty close. 2 threads and 1 thread. So my takeaway from all this is that the 5900HS is, well, a beast of a processor. It punches way above its weight class. And I also just wanted to note about how much Intel managed to improve their laptop processors with 4 cores over the time. At the time that I purchased the 1067 G7, I did not see the AMD Ryzens on the horizon. Otherwise, I may have considered buying one of those laptop models as opposed to the Intel 4-core, because Intel was competing a 4-core laptop versus an 8-core laptop. The only advantage with Intel being Thunderbolt. And I think they had faster USB speeds, but Thunderbolt was kind of the main one. But even the 8259U had Thunderbolt. So I'm looking forward to seeing what AMD does with the 6000 series mobile. But personally, I think that if you can get your hands on a AMD current generation 5000 series, you're going to be very happy with the performance that you get out of it, depending on what your use case is. It certainly is a well-rounded machine, as I wanted to demonstrate with these graphs and charts. Thank you very much for watching my video, and have a great day.